So now we started with the external interrupt programming, how to write a program for external interrupt. Okay, before we start with the external interrupt programming, do that programming. So you need to follow this step closely. So if you follow this step closely, inshallah, I can assure you you can answer the interrupt programming question. These are the steps that you're going to do lah. Okay, to follow. Okay, the first one here you need to include the interrupt header. Okay, in order to do that, just write down hashtag include avr slash interrupt dot h. Okay, this is the first thing first that you're going to do. Okay, include this file. The second step, okay, after you write down your main program, okay, starting with int main void upon curly bracket, close curly bracket. So inside of your main program, so you need to initialize the interrupt IO port. Okay, so how to initialize the interrupt IO port? Okay, so you know that you have three external hardware interrupt, which is INT0, INT1, and INT2. So you need to know where is the location of this IO port of these three interrupt here. Okay, for INT2, the interrupt located at the port D pin number 2, INT1 at port D pin number 3, and INT2 it is at port B pin number 2. Okay, so after you initialize the interrupt IO ports and any other in IO ports that you're going to use, then after that you need to follow the third step is enable the interrupt. Okay, to enable the interrupt, you need to enable at two locations here, or one we call it as a interrupt register, the other one is at the status register. Okay, so if you using the external hardware interrupt, you need to enable interrupt at GICR. If you use a timer interrupt, you need to enable at TIMSK register. Okay, so now we focus on the external hardware interrupt. Okay, so in external hardware interrupt, so this is your GICR. Okay, so GICR, there are three bits that you're going to know. Okay, the bit number 7 here dekat sini, this is the first bit, the second bit, and this is the third bit. Okay, only these three bit, the rest you just ignore. Okay, so bit 7 for INT1, bit 6 for INT0, and bit 5 is for INT2. Okay, if you want to enable this interrupt here, okay, you just put 1 lah. Okay, at this bit. If you put 0 means that you're going to disable that interrupt. Okay, let's say like if I put 101, what happen is I want to enable INT1 and INT2, while INT0 I disable. Alright, so before we proceed with the status register, we need to enable the interrupt trigger. Okay, why we need to enable the interrupt trigger? Later we'll see the reason why we need to enable this interrupt trigger. Okay, there are two registers that you need to know in order to enable the interrupt trigger. Okay, the first one we call it as MCUCR. The second one we call it as MCUCSR. So MCUCR used for INT1 and INT0 only. Okay, so this register only dedicated for INT1 and INT0. So in this register here, MCUCR register, okay, you need to focus only at this bit here. Alright, so every time you put 00 at this bit, what happens is, okay, it means that when level 3, it means that the interrupt will evoke when it sends the level trigger, which is a 0. Okay, it's something like this lah. Okay, this is your switch, right? Your switch is always a active low switch. Okay, so when you release your switch, what happen is it will produce logic 1. Okay, when you press your switch, it produce logic 0. Okay, and when you release back, it produces logic 1. Okay, so this is what we call as a level. Okay, level is either logic 1 or logic 0. While edge triggered, okay, for the edge triggered, okay, you see here, when you press your switch, what happen is the logic here will change from 1 to 0. So this one here we call it as a falling edge. While when you release your switch, okay, the level here will change from 0 to 1. So this one here we call it as a rising edge. Okay, so this is how the interrupt will be invoked. Okay, will be triggered. Either it's a level triggered or edge triggered. Okay, if you put 0 0 means that it will trigger every time the micro see the level 0. Okay, when you put 0 1 at this bit here, okay, the interrupt will be triggered, okay, when the micro PC either when micro PC falling edge and rising edge. For example lah, if you press the switch, okay, the interrupt will invoke, and then when you release back your switch, that interrupt will be invoked again. Right? When you put 1 0, what happens is the interrupt will be triggered only every time the micro PC the falling edge. When you put 1 1 at this bit here, okay, the interrupt will be triggered every time the micro PC the rising edge. Okay, this is for the MCU CR lah. For the MCU CSR, okay, this one here for the INT2. Okay, see, this is for INT2 only lah. The level triggered for INT2. If you put 0, okay, so INT2 also 8-bit wide. Okay, so you need to focus here on this bit here. Okay, bit 6 kat sini. If you put 0 at this bit here, what happens is it is a falling edge. If you put 1, this is for rising edge triggered. Right, so this is for the interrupt triggering lah. Either it's level triggered or edge triggered. And then after that, you need to enable at your status register. Okay, so status register also 8-bit wide. Okay, the flag that you need to focus here is your flag I flags. Okay, if you put 1 at your I flag, means that you want to enable your interrupt globally. If you put 0, you want to disable your interrupt globally. So how to put 1 and put 0? By using the SKEE or CLI instructions. Okay, so we finish here. Enable to enable the interrupt. This is the third step. Okay, the fourth step. Okay, you write down all your program lah. Okay, inside your main program, right? Okay, your main program. Anything that you want to write in your main program. And the final step is step number 5. Okay, your ISR, interrupt service routine. Okay, you need to write your interrupt service routine. How to write the interrupt service routine? Okay, so you need to know lah. Okay, this is how you're going to write the interrupt service. ISR, okay, open bracket here, and then the ISR names. Okay, make sure that ISR name is correct lah, according to what type of interrupt that you're going to use. If you want to use INT0, so please write down INT0 underscore Z PECT. INT1 underscore Z and so on. Make sure this name is correct. Okay, you can refer to the previous table for the interrupt service routine name. Okay, so under this interrupt service routine name, you write down lah all the tasks that you're going to do whenever the ISR is triggered. Okay, so remember this 5 steps. Inshallah, you can answer the question. Okay, you can do the interrupt programming. Okay, so again we just recap back. All right. So there are three external hardware interrupt that you need to know. The first one we call it as INT0, INT1, and INT2. Okay, so INT0 located at PD2, INT1 located at port D, pin number 3, and INT2 located at port B, pin number 2. Okay, so the hardware interrupt must be enabled. Okay, so this is the third step. Okay, you need to enable your hardware interrupts. Dekat mana kita nak enable? Dekat GICR. Okay, before the interrupt can take effect. Okay, if you not enable at GICR, you only enable at your status register. Your okay, every time you invoke your interrupt, the interrupt will never occurs. Okay, if you enable at GICR but you forgot to enable at status register, when you invoke your interrupt also never occurs. Okay, you need to enable at both register, GICR and status register. If you use the external hardware interrupt lah. If you use the timer interrupt, you need to enable at TIMSK and status register. Okay, there are two locations that you need to enable. Okay, don't forget to enable at both locations. Alright, so this is your GICR. This is the detail of your GICR. Alright, so as I mentioned earlier, GICR have berapa bit? 8 bit wide. Okay, you need to focus only at these 3 bits only. Okay, bit number 7, INT1. This is INT0 followed by INT2. Okay, if you put 0 means that you disable the interrupt. If you put 1 to this bit here means that you want to enable that interrupt. As easy as that. Okay, so let's do an example here. Okay, so you're going to enable INT0. How to do that? Okay, so INT0. So this is GICR. So you need to know lah your GICR. Okay, so this is INT1, INT0, this is INT2. Okay, to enable INT0, so you need to put 1 at INT0 while the rest is 0. Okay, how to write down in C programming? Just write down GICR equal to 0B. Okay, for this kind of operation, I always use the binary number. Why? Because I can know where exactly the interrupt, the location of interrupt that I'm going to enable. Okay, so this one here 0B 01. Okay, disable INT1, enable INT0, followed by disable INT2, and the rest just put 0. Ataupun if you want to use the Hesa number also can. Okay, you can write down. Okay, this alias atau GICR. Okay, so this one here equal to 0x for 0. Okay, you can use binary or hexa, but I advise you to use the binary so that you can see. Okay, you can know that the what you call the correct INT that you want to enable. Okay, so the INT0 is a low level trigger interrupt by default. Okay, by default it is a low level interrupt. Why low level interrupt? Because every time, okay, remember every time you switch on your micro P, what happened to your, okay, so this is your data memory. Okay, recall back. Okay, all of the previous slide are connected. Okay, you need to recall back. Okay, so this is your data memory. Data memory can be divided to 3 parts: GPR, IO, and RAM. So since every time you switch on your micro P, what happened to your data memory? The value on side of this one time memory will be erased, which is got 0. Okay, so all the GICR, MCUCR, MCUCSR, CSR, status register, okay, your DDRB, DDRC, all are inside of your IO register. Okay, by default, okay, you see here, by default, okay, the INT0 is a low level trigger. Why? Okay, so recall back your MCUCR. This is your MCUCR. Okay, so 4 bit that you need to focus here. Okay, which is this one and this bit here. Okay, this is INT0 and the INT1. Since every time you switch on your micro P, the value inside of this register are 0. Okay, you see here what happens when you 00 in this MCUCR. You see, when 00 is a level triggered, which is it will trigger every time the micro P see the level 0. Okay, so that's why by default the INT0 is a low level trigger. Okay, so when a low signal is applied to your pin D2, why PD2? Because INT0 is located at port D, pin number 2. Okay, so this is your switch. I need to padam here first because I draw it. Alright, wrongly draw it. Alah, salah lagi. Oh, sorry. Alright, mistaken here. Erase. Not this. Alright. Okay, now we're correct. Okay, so this is connected to PD2. Okay, since okay for interrupt we use the active low switch. Okay, so every time you press the switch, what happen is it will produce 0. Most of the time it will produce 1. Okay, so this is your logic 1. Okay, this is when you not press your switch, you release your switch. Okay, what happen is when you press your switch, it produces only 0. This is when you press. Okay, this is where you release your switch. Okay, by default, okay, when a low signal is applied to PD2, okay, when you press, okay, so this low level lah, okay, the controller will be interrupted and jump to your INT, bukan INT2 this is INT0 underscore vet in the vector table to service your ISR. Okay, so this is what happened. Okay, if you're going to use the INT0. Okay, let's look at this example here. Okay, assume that the INT0 pin is connected to a switch that is a normally high. Okay, normally high means that it is a active low switch. Every time you press your switch, it will produce 0. Write a program that toggle port C pin number 3 whenever the INT0 pin goes low. So how to write down your interrupt programming? Okay, first thing first, what are you going to do? Okay, of course lah, you need to add this one. Betul tak? Okay, include avr/io.h. This is the IO header. Okay, the AVR header. So you need to include this header here. And then the first step that you're going to do, what is the first step? Include your AVR slash interrupt.h. Okay, so this is your first step. Okay, done. Okay, then start with your main program, INT mainboard, open curly bracket, close curly bracket, and then what is the second step? Initialize the interrupt IO port. INT0. Where is your INT0? Dekat mana? PD2. Okay, so you need to initialize your PD2. Where is your PD2? Okay, this one here, DDRC equal to 1. Okay, shift to the left 3 times. Okay, DDRC. What is DDRC? Okay, this one. Okay, because you want to toggle port C, so you make your port C as a output port. Okay, so this is the lukisan lah, the drawings, the circuit of your Mega 32s. Okay, this is your port C, and this is your port D, in which your port Ds are connected to your what we call here, to your switch. All right, so every time you put 0 here, okay, the interrupt will trigger. So now you know that the port C now need to initialize as an input port, while this one here as a output. Okay, so what is the second step? Initialize the interrupt input output port and other IO ports. So this is the second step. DDRC equal to 1 shift to the left by 3, ataupun you can replace this one. If you don't want to do this, you can replace DDRC equal to, okay, since you only use the one port C here, you can either make it as a, sorry, this is input, okay, this is output. Okay, so you can make it on the whole as an output port. Okay, or if you don't want to do that, you can write down DDRC equal to 0B, okay, 0 0 0 0. The rest you put 0. Only bit number 3 you put 1. Also can. Okay, and then DDRD equal to DDRD and with tilde. Okay, 1 shift to the left by 2. So this one here, you're going to initialize your port D pin number 2 as a input port. How to do that? By sending 0 to your DDRC. Okay, since only port D2 is used as an input, so why not we just, okay, to make it simple, DDRD equal to 0. As simple as that. Okay, ataupun if you don't want to do this, you can also write DDRD equal to 0B. Okay, the rest you put 1. Only port D bit number 2 or pin number 2 you put 0. Also can. Okay, after that, okay, because this is connected to your switch, okay, you need to know that whenever you connect your input to your switch, you need to enable your pull up resistor. How to do that? Okay, by write down port D equal to 0B 0 0 0 0 0 1 0 0. Okay, put 1 to your port D. Ataupun if you use this DDRD equal to 0, you can enable by typing port D sama dengan OX sama. Okay, you can use either one, or you can use this one lah. If you're not confusing with these things here, these tilde things. Alright, this step number 2. What is step number 3? You're going to enable your interrupt. So how to enable your interrupt? Okay, first you need to know lah. You're going to use the INT0. So where is the what register that you need to use in order to enable INT0, which is the GICR. Okay, from GICR you need to know lah. Okay, GICR you have 8 bits. Okay, where is the location of GICR? INT0. So this is your INT0. Okay, so what is the value that you're going to put to your INT2? I put 1, 0, 1, 0, 0, 0, 0, 0, 0. Okay, so this one I just write down here. Okay, you can use this what we call here uh, this instruction here. Okay, which is this one here is it means that okay, shift 1 to the left until it reach the INT0 location. So this is your INT0. Okay, ataupun this one here, instead of you put the INT0, it also similar to shift 1 to the left how many times? Okay, 6 times. Okay, 1, 2, 3, 4, 5, 6. Okay, if you don't want to put the 6, you can put INT0. The micropino INT0 at bit number 6. Ataupun, okay, if you confused with this the way of you write down this instruction, okay, you can use the simple instruction GICR equal to 0B. Okay, so this is the value 0, 1, 0, 0, 0, 0, 0. Just simple as that. Okay, just write down this one. Okay, okay, you already enabled the GICR. Next, enable MCUCR. Okay, in this case here, we not enable MCUCR. Why? Because we want to see what happens if you don't enable your MCUCR, the interrupt trigger level. Alright, and then in the third step also, you have two locations that you need to enable. One at the GICR, the other one is at your status register. So how to enable in the iFlag in status register? Just write down the SEI, open curly bracket, open bracket, close bracket, and semicolon. While one, okay, so this is what happened here. This is your program lah. This is your step number 4. Okay, if you have any program, you just put under this while loop here. If not, you just leave it blank. Okay, and last but not least, if your step number 5, okay, so this you stop close your curly bracket of your main program and start with your ISR subroutine. Okay, so how to do that? Okay, how to do a step number 5? Okay, so ISR, okay, make sure that the name is correct, INT0 underscore vet, okay, because you're using that INT0, open curly bracket and close curly bracket. So in this case here, what happen is you're going to toggle port C pin number 3. So you just use port C equal to port C exclusive or with shift 1 to the left by 3. Ataupun serabut lah this one. Okay, you can use 0B 0 0 0 0 1 0 0 0. Just like that. Okay, so every time you switch, okay, so what happen here, every time you press this switch, the port C will toggle. The interrupt will invoke and port C will toggle, okay, from 0 to 1, and you press again, it go to 1, and when you press again, it become 0. It will toggles continuously depending on your switch here. If you press, it will toggle. If not press, and then it will not go to this ISR. So what happened by the time Microprocessor finished ISR, which is ISR is exited and INT0 still low. Okay, something like this. Alright, so whenever the switch INT0 is activated, okay, so this is your switch lah, this is your PD2. It's always 1. We will not press. When you press, okay, it will produce logic 0, right? So this you press, okay, press switch, okay, produce logic 0, okay. Okay, so whenever the INT0 is activated, okay, when you press this switch here, so INT0 is activated, so the macropy will get out the loops, okay, will get out from this loop here and jump to the ISR. Okay, it will go to this ISR. The ISR for INT0 toggle the PC3. But if by the time it execute the this one, yeah, okay, the curly bracket, which is it finish the ISR, but the INT0, okay, still low. Okay, the value still low. Okay, you still means that you still press the switch. You not release the switch. What happened? Okay, so what happened is the micro P will initiate the interrupt again. Okay, so the micro P will go again. Okay, so it's in, since the value here, right, still 0. Okay, so it's saying that okay, we need to initiate the interrupt again. So what happen is it will go back to do this ISR, toggle the value, and if it when it finish and it see the value still low, and it will go to interrupt again. Okay, okay, until you release your switch. Okay, when you release your switch, you finish execute this ISR here. What happen is then it will stay here because now you release your switch, the value here is no longer 0, which is the logic 1. Okay, so therefore, if you want to the ISR to be executed once, means that when you press your switch once, okay, the interrupt, the ISR will invoke only 1. Even though you not release your switch, the ISR executed here only 1 time. Okay, so the INT0 must be brought back down before RT. Those should make the interrupt edge rate. So that's why we need to use the MCU CR to avoid this thing happen. Okay, to avoid that the interrupt will go continuously okay, or to avoid the interrupt will trigger continuously until you release your switch. Okay, that is the reason why you use the MCU-CR and MCU-CSR. Okay, so as I mentioned earlier, okay, there are 2 types of activation for external hardware interrupt: level triggered, okay, for INT0 and INT1, edge triggered only for INT0, INT1, INT2. You see here, INT2 doesn't have level triggered. Okay, so if you, okay, only INT0, INT1 have the level triggered. So in this case here, if you're going to use the edge trigger, you don't want to use the level trigger because you don't want this scenario happens. All right, so what happens is you need to set your MCU-CR and MCU-CSR. Okay, so for the MCU-CSR, okay, used for to indicate whether INT0 is active in falling edge or rising edge. So this is MCU-CSR, MCU-CSR. Okay, so when bit 6 here you put 0, okay, the falling edge of INT2 generate as interrupt request. If you put 1, the rising edge of INT2 will generate the interrupt request. So this is only for INT2 lah, MCU-CSR only for INT2. Okay, so for MCU-CR register, okay, so it indicate the trigger option of INT0 and INT1. So where where is the location that you need focus? Only these 4 bits here. Okay, bit 0, 1, 2 and 3. Okay, so bit 2 and bit 3, this is for INT1, while bit 1 and bit 0, this is for INT0. Okay, so when you put 00 means that it's a low level triggered. Okay, the low level of INT0 will generate an interrupt request. If you put 01, any logical chain on INT0 generate an interrupt request. Okay, either it's falling edge or rising edge, it will generate the interrupt request. If you put a 10, this is only falling edge. Okay, the falling edge of INT0 will generate the interrupt request, and when you put 11, the rising edge of INT0 will generate an interrupt request similar to your INT1 lah kat sini. If you put 00, level triggered, 01, any logical change, 10, falling edge, 11, rising edge. Right, so let's do this example here. Okay, show the instruction how to make INT falling edge triggered. B, make INT1 trigger on any chain, and C, make INT2 rising edge triggered. Alright, so first one, how to make INT0 falling edge triggered. So for INT0, we need to look at MCU-CR. So MCU-CR, this is your MCU-CR, 8 bits. Where is the INT0? So this is your INT0. How to make INT0 falling edge triggered? Okay, you need to know 00, this level triggered, 01, any logical, 10, falling edge, 11, rising edge. So you just write down MCU-CR sama dengan, okay, so this one you need to put in the falling edge. So falling edge you need to put 10. Okay, so 0B 0 0 0 0 0 0 1 0. Okay, so this is a falling edge trigger for INT0. Okay, or you can put in hexadecimal also. Okay, B, make INT1 trigger on any change. Okay, INT1, where is INT1? This is INT1 lah. Any change, you need to put 01. So 01. What about the rest? You put 0 lah. Okay, so MCU-CR equal to 0B 0 0 0 0 0 1 0 0. So this is any chain for INT1. Okay, or you can also write down something like this lah. MCU-CR put 1, shift 1 to ISC10. You need to know lah this name, the bit name. Okay, ISC10. You see ISC10. This is ISC10, which is bit number 2. Okay, you can use this kind of instruction here, line is here. Alright, and to make INT2 rising edge. Okay, INT2, where is your INT2? At your MCU-C SR. Okay, where is the location of INT2? Dekat bit number 6. If you put 0, what happens when we put 0? This is falling edge. When you put 1, this is rising edge. Okay, so now you want to rising edge, so you put 1 here. So what happens? MCU CSR equal to 0B0 1 0 0 0 0 0 0 0. Just like that. Okay. Next, we look at examples. Okay, so rewrite the previous switch example so that whenever INT0 goes to low, it toggle port C only once. Okay, so every time you press your switch, it only toggle the port C only once. Means that it only trigger the ISR only once, not multiple times, only one time until you release the switch. Okay, all of these things are similar to the previous one. Okay, this is the first step, this is the second step, this is the third step, okay, you see there, inside of the third step, you put the MCUCR equal to INT0 goes low. Ingat lagi tak? INT0 dekat mana? Dekat MCUCR lah. So this is your MCUCR. So what is the value that we need to put? So this is INT0, 0, any level, 0, 1, any logical change, 1, 0, falling edge, 1, 1 is rising edge. Okay, so this one here, you can use either falling edge or rising edge. Okay, so if you use the falling edge, alright, so you can put MCUCR equal to OX02, ataupun this one here you can replace with MCUCR equal to 0B00000010. If you're going to detect the interrupt falling edge lah. If you're going to detect interrupt rising edge, you just replace this value with 1. Okay, this is step number 4 and this is step number 5. The rest is similar, only you add this line here.